Hello everyone, I'm Dr. Rajesh and I am again with you with my new video, and in this video we will be studying numerical problem on projectiles, and the numerical problem will be based upon the velocity article that we did in the last video. And the statement of the problem is given by: if at any point of a parabolic path velocity be u and the inclination to the horizontal be alpha, show that the particle is moving at right angle to this direction after time u by g cosecant alpha. So if at any point of a parabolic path velocity be u, so for this purpose let us draw the figure, and the figure is this one. This O is the uh, point of projection. This is horizontal axis, this is vertical axis. Now, if at any point of a parabolic path velocity be u, let us say any point on the parabolic path be this point. Say this is P, any point, and at this point the velocity, if I say, is u at that particular point. So once again read out the statement: if at any point of a parabolic path velocity be u, so this velocity at this particular point, say this point, is u, and angle it makes with the horizontal is alpha. Fine. So next read out the statement: show that the particle is moving at right now, it is moving at an angle alpha. So show that the particle is moving at right angle to this direction. So right angle to this direction will be direction something like in this particular direction. In this direction it will be right angle direction. So particle will be moving in that particular direction after time t. So let us say that after time t, particle is here. Particle is here at point q, and draw a tangent, and tangent is drawn like that. And let v be velocity at that particular point. And the angle that it makes with horizontal is say theta. Now here see, we know that angle on this line is 180 and this is alpha. So this particular angle will be 180 minus alpha. So if I say that this angle is 180 minus alpha, and then we know that in a triangle total angle is 180. So this is theta, this is 180 minus alpha. So what this angle will be? This angle will be, if I name this as, say, this is named as A, this point is named as B. So angle ABO plus theta plus 180 minus alpha, sum of the angles of a triangle is equal to 180 degree. This will cancel out. This implies that angle ABO plus theta minus alpha is equal to 0, implies angle ABO is equal to alpha minus theta. So this angle, if I say this angle is alpha minus theta. So now given condition is that when after time t, if I write when after time t, this velocity vector v becomes perpendicular to velocity vector u, where we assume time we start measuring from that point P, and after that time point lapse of time t, we have vector v. So if this vector v is perpendicular to u, then in that case, if I say this alpha minus theta will be equal to 90 degree, so this angle will be 90 degree, because if we see, if this angle is alpha minus theta, so this angle will also be alpha minus theta, because vertically opposite angles. So this angle will be alpha minus theta also. So that is angle between, this is angle between u and v. What is that? Alpha minus theta. And when this u and v will become perpendicular, so this angle will be pi by 2. So this implies that theta is equal to alpha minus pi by 2. So this is the relation that we have to keep in mind, and you may name it as equation number 1. Now, since at point P we have assumed that time we start to measure from the point P, so from this point we start to measure the time. So the velocity at this point is initial velocity. So if I resolve the components at that particular point P, so it will have two components. One will be u cos alpha and another will be u sin alpha. And if I resolve the components of velocity vector v at this particular point, then if I say this is the line, and if I say, and this angle is theta, so this component is v cos theta and this component is v sin theta. So this implies that this component will be v sin theta. So using the formula, v is equal to u plus ft. V is the velocity after time t. Vertical component, in vertical component it will be v sin theta, and it is initial velocity. Okay, vertical component of the initial velocity. Initial velocity is u sin alpha, and f is negative because the motion is against the force of gravity. So this is like that. If I write here as, so this implies that, and here it will be v cos theta, because the horizontal component always remains the same, it is not going to change. So may I name it as equation number 2, and we may name it as equation number 3. So now dividing 3 by 2, we get, this will cancel out. This implies that tan theta is equal to tan alpha minus gt by u cos alpha. So next we see that using equation 1, where theta is equal to alpha minus pi by 2, I can write here as, using equation 1, we get tan alpha minus pi by 2 is equal to tan alpha minus gt by u cos alpha. This implies that tan minus pi by 2 minus alpha is equal to tan alpha minus gt by u cos alpha. And we know that tan minus theta is minus tan pi by 2 minus alpha is equal to tan alpha minus gt by u cos alpha. And you mention here that tan minus theta is equal to minus tan theta. This implies that it will be minus cot alpha is equal to tan alpha minus gt by u cos alpha. This implies that gt by u cos alpha is equal to tan alpha plus cot alpha, which is further equal to g by t u cos alpha is equal to sin alpha by cos alpha plus cos alpha by sin alpha. So this is equal to cos alpha sin alpha, it will be sin square alpha, it will be cos square alpha, and we know that sin square alpha cos square alpha is 1. So this will be 1 cos alpha sin alpha. Cos alpha to cos alpha will cancel out. This implies that t is equal to u by g sin alpha implies t is equal to u by g cosecant alpha. So which is the time taken by the velocity vector to become parallel to the velocity vector at point P. So this much time is taken. So this is the problem that we have dealt with, and this is very important from the examination point of view. So you should take note of it. It is very important from examination point of view. So this is all I have from this lecture, and if you have any query you could write me in the comment section. So your comments in the comment section are always welcomed, valued and appreciated. This is Dr. Rajesh saying you all goodbye, take care, bye bye. Thank you very much. Thank you for watching.